Good evening, students. How are you today? I hope you have been practicing the examples of a per unit system. I will take you through example 6.4 in case there is any area where you are struggling. Example 6.4. It says figure 6.6 shows a schematic diagram. This is 6.6. Shows a schematic diagram where you are given the voltages of the transformer and 600 kilowatts. The power factor is 0.8 lagging. This is the generator, this is the transformer, and this is the line, while this is the load. You are given this radial transmission system. This asks us to use the nameplate value of the transformer. That means we are going to use the nameplate value of the transformer as the base values. Then we must calculate the terminal voltage. We want to know the terminal voltage on the generator. If the load draws a full load current at 0.9 per unit. So invariably, what you want to do is you want to determine the terminal voltage at the generator. If you know the V per unit here, it will be equal to the V per unit here plus V per unit here plus V per unit here. That means the V per unit of the generator is supposed to be equal to the V per unit of the transformer plus V per unit of the line plus V per unit of the load. It's just like when you have the voltage from the generator, the terminal voltage here being equal to the drop in all these components put together. That is exactly if also translated in the per unit system. So when you get the V per unit of the generator, you can use it to determine the terminal voltage of the generator. And to do that, you can get started with the load point that will help you to determine the I per unit, because this V per unit of the transformer is supposed to be equal to I per unit of transformer times Z per unit of transformer. Something like that. Also, I per unit, because I per unit, the current is common to them. So if you have the I per unit of the transformer, if you have the I per unit of the load, it will give you the V per unit in transformer. That is I per unit times the Z per unit here will give you the V per unit here. The I per unit times the Z per unit of the line will give you the V per unit on the line. And of course, you are given the V per unit of the load in the question. So let us try to go through it. You need to determine I per unit. And to determine I per unit, you need to, for I per unit that you are looking for should be equal to I load divided by I base. Let's not forget that I told you per unit is the actual over the base. So the actual current flowing through the load is the high load, while the base current that has been determined will be the one that will be that we use to divide the I load to give you the I per unit. Now, I load, getting I load from the information in the load component. You said your P load, which you are given to be equal to 600 kilowatt. Your P load is equal to root 3 V load, I load, cos phi load. That is root 3 VI cos phi. That is the power, the active power that the load is drawing. Then your P load is given as 600 kilowatts. 600 times 10 to power 3, which is equal to root 3 into the V load, which is the voltage across the load. The voltage across the load, let's not forget that I told you we have two sides to the transformer. This side of the transformer, which is the primary side, and this side of the secondary